Hey everyone, here's one more example of an exponential graph. We'll start by noticing that because the graph is translated down 1 unit, the asymptote's going to be at y equals -1. Next we identify our a value and our b value. Starting with the b value, the base is 2. And the 2 is what's touching the exponent, so that means that b is 2. And since b is -2, that means that a has to be -1. It's really important to remember for the exponential graphs that the base is always positive. Since a is -1, I know that that would originally have been the y-intercept. And then because of the translation, we're going to move that down 1 unit. Now, knowing that my base is 2, which is greater than 1, and knowing that I have a reflection over the x-axis, I know my graph is going to look like this. So an exponential growth graph upside down. And now I just need to pick another x value. Again, I can pick any x value that I want. But to get an easy exponent to work with, it might be nice to use what would give me an exponent of 1. So since it's a growth graph, a positive 1 exponent would be more useful. So by setting 3x equals to 1, I find that I can put in x equals 1/3 to the function, and then f of 1/3 after I plug it in and evaluate it gives me -3. Again, it's more useful to see the shape of the graph to pick a point on the right side of where we moved our y-intercept to, just to give us more idea of the steepness. Again, remember though, a graph is just when you plug in the x's, get the y's, and connect all of them. It does not matter what x value you pick. You can substitute any x value that you want and get the y value and use that point and still have a good looking graph. In other words, don't overcomplicate it for yourself. So finally, I'm just going to draw my second point and then finish drawing the curve. So there's your graph, and again remember, the goal is not to get a pretty graph or a really complicated graph by plotting a bunch of points. We are really interested in which direction the graph goes. You know, where does it approach its asymptote, and where does it go off to one of the infinities? Where's the asymptote at? What shape is it? And what are some of the points? If you can get this information down, you have a really clear idea of what you're looking at. And again, sometimes the information you draw on the graph will just depend on what you're trying to do with the actual problem you're using the graph to solve.